Thank you. Okay, so hi, I'm Ladan Khandal. I'm going to be presenting on the research I did as a grad student at UC Berkeley and Lawrence Berkeley National Laboratory on gel nail polish. This work was done with the help of my colleague Kelsey Ranchbar and Marion Russell from Lawrence Berkeley National Lab. My thesis advisor from Berkeley was Catherine Hammond, and my advisor from LBNL is Randy Madalena. So gel nail polish is, at the time I was starting this study, it was super popular. That was around 2018, super popular. I don't even think dip was really a thing back then. And I personally just really liked getting my nails done, both at home. I had a home kit, and I would also go to salons pretty often to get my nails done. And gel is really popular just because it adds a lot of strength to the nails. It's applied as a liquid polish, and then you dry it under UV light and it forms this hard shell. It lasts a lot longer than a traditional nail manicure compared to evaporated nail polish. And at the time that I was starting this study, I noticed that there was quite a bit of research done on general volatile organic compounds released in nail salons and from traditional nail polish, but not much had been done to look directly at gel nail polish. And I mean, it's clear that there's a chemical reaction going on there when you apply it as a liquid and it dries as solid. So I basically just wanted to investigate to see what's going on during this manicure process and see if there's any just try to establish a chemical profile for a gel manicure. So all the sampling was conducted at Lawrence Berkeley National Lab. I built this chamber that you could see in the photo and tried to mimic exactly what's done in the salon. I set the ventilation rate inside the salon, inside the chamber, to be similar to that of a salon with an open door and windows. And we purchased these tiny nail sticks, and we would just paint 10 of them, just try to make it as close to a manicure as possible. The manicure process for the purpose of this study was a coat of primer, 1 coat of base coat, 2 coats of color, and then a top coat. And we did 6 different colors. I tried to collect nail polishes from salon donations. I bought a couple online, and then I also bought a few in the store just to try to get a diverse variety of sources, try to capture maybe if there's a difference between salon products versus consumer products. And so for the sampling, we actually measured the concentration of volatile organic compounds between 21 to 240 grams per mole. And the white box attached to the chamber in the photo, that's a proton transfer reaction mass spectrometer. So that one, it's really, really sensitive, and it reports all the concentrations, but it doesn't tell us the identity of the chemicals. So we just conducted the study, and then we verified all of what we were seeing from the proton transfer reactor to gas chromatography. So that was our way of kind of playing matchup of what we see from that machine and then validating it through GC. So overall, the highest concentrations we saw were for isopropyl alcohol and ethyl acetate, and then another chemical that's still unknown. It has a molecular weight of 42, but we weren't really able to identify that. The PTRMS does have some fragmentation, which means that larger chemicals can break off into smaller ones, and this unknown chemical is likely a fragmented chemical. And so altogether, those 3 ions, isopropyl alcohol, unknown mass 42, and then ethyl acetate, made up 87% of the total mass of all VOCs observed. We did see increased concentrations of formaldehyde, benzene, acetaldehyde, methyl methacrylate, and isopropyl alcohol, and toluene and methacrylic acid, among many others. What was really important about this study was kind of just the way in which the chemicals appeared. So I pulled out 2 specific graphs. So the way that we designed the study, it was easy to kind of track the emission patterns. And on top here, we have formaldehyde, and we could see that it's emitted pretty gradually during the painting process and then reaches a peak toward the end of the paint. So we see that formaldehyde likely isn't present in the primer, but it is present, likely being released during the nail drying process. And formaldehyde wasn't listed on any of the safety data sheets, so it's highly likely that it is being released secondarily during the nail drying process. And we can contrast that with acetaldehyde, which is, we see a peak really suddenly at the primer phase, and then it kind of just gradually exits the chamber after that. And that suggests that acetaldehyde is likely a factor mostly in the primer and not so much in the paint products. So with all the data we collected, I also did an exposure assessment model using the near field far field model. I think it was coined by Mark Nickus from UC Berkeley. And basically with this model, you imagine a certain area to be the near field. That's where all of the exposure is really happening. That's like the source of the exposure. So for this study, we just imagined kind of an 8-inch semisphere on the table, which is where the manicure is occurring. And the 8 inches away is supposed to be kind of like the breathing zone of the nail technician or whoever's doing the nails. And the far field is represented by basically just the salon, a salon with open doors and windows. So we applied some assumptions based on data I collected from just looking online, and the UCLA nail files documentary was, the document was also really helpful for this. And basically with this one, we found that none of the results exceeded any of the Cal-OSHA permissible exposure limits. The OEHA acute recommended exposure limit for isopropyl alcohol was exceeded, and the 8-hour recommended exposure limit for acetaldehyde got pretty close to the limit of 0.3 milligrams per meter cubed. And we also found that a higher air change rate in the salon, like having increased ventilation, opening doors and windows, that helps a lot with reducing concentrations in the far field or the salon, but it doesn't really do much to help with concentration in the near field. So this suggests that really the most helpful way to reduce salon exposures would be local exhaust ventilation placed directly where the manicure is happening to kind of soak up all of those breathing zone exposures. And another thing that I want to know is that these findings don't indicate that the air in salons can be considered safe. As we know, there's so many different products being used in nail salons. There's very little regulation about what's in them. And oftentimes there's a high number of people doing the work at the same time. And it's really hard to say what the ventilation rate is like. Sometimes they don't open doors and windows. Sometimes they are very small salons and everyone's working close to each other. So some of the limitations of the study, it was done in the lab, and like I mentioned, it's kind of hard to replicate exactly what's going on in the salon, but we did our best. And a lot of the ions that we detected with the PTRMS couldn't be definitively defined by GC. This was kind of just due to different lab limitations. This was all work that I did kind of opportunistically, because since I was already working in the lab, I just kind of asked them if I could use this instrumentation to conduct my experiment. And so the gas chromatograph that we used was really better suited for semi-volatile organic compounds. So the lower molecular weight ones, the higher volatility ones were pretty hard to identify. And another thing is I realized after that I really should have looked at the primer and the top and base coat each separately. I just did it straight as though it would be conducted as a salon, just because I wanted to get a good picture of what's happening during a manicure. But we could have benefited from more data about each product individual. So what does this all mean? Toluene, formaldehyde, benzene, and methyl methacrylate, those are 4 big chemicals that they obviously have really severe health impacts, and They have been measured in nail salons, but I didn't expect to find any of them in gel nail polish since none of them were listed in any of the safety data sheets. And under OSHA hazard communication standards, carcinogens, reproductive toxicants, sensitizers, they would all need to be disclosed in the safety data sheets if they're in the original formulation of the product. So this brings up kind of a possible loophole where these chemicals, they might be formed secondarily, or they might have been unintentionally added where they would be classified as an incidental ingredient and thus would not need to be disclosed. And benzene and formaldehyde are both known human carcinogens. Toluene is a reproductive toxicant, and then methyl methacrylate has been banned since 1974, I think. So some of the future directions, I'd really like to go back and identify all the remaining chemicals. We have so much data on concentrations, we just can't identify what they are just because of the lab limitations. And we need more studies in nail salons to be just to help us get a better understanding of what's going on. And as always, advocating for more ventilation, PPE, warning labels, getting the support of regulatory agencies to help develop strategies and reduce chemical exposures. Really the best way is education-based training for both workers and owners. And I think outreach programs should really focus on the benefits of reducing these exposures rather than on workplace violations and penalties.